lecture 11B part 2. So we're still on area moment method, but now on our second lecture. So today we'll be discussing more examples and a different way of solving parts of your area moment method. Okay, so as a recap, balikan lang po natin yung first area moment theorem. It states that the relative slope theta d with respect to C between 2 points, C and D, on a beam is just equal to the area of the M over EI diagram with respect to CD. Now, if you've tried solving yung ating quizzes or part 1 of this lecture, quiz number 2 was particularly difficult in coming up with your M over EI diagram. Kaya yun yung solving natin na problem nung method this lecture. Okay? So, to recap again, your M over EI diagram looks like this. So, the area is the shaded region. So, the sign convention for this slope, if it is positive area, it's counterclockwise. So, relative slope po yung counterclockwise. Ha? So, ito, from C to D, kasi D with respect to C. So, you can understand that D to C, so ito yung tangent at D, to C, ganun din. Okay? So, yung negative area naman is clockwise. So, clockwise naman si theta D with respect to C. So, C to D. Okay? So, the second area moment theorem naman, TD with respect to C, is stated as the area between the 2 points times x bar, or the centroid of the area, measured from the reference point, yung numerator na D. So, to illustrate that, if you have an M over EI diagram, so this is the deflected curve, PD with respect to C is this one. The final position of D to the distance to the tangent line at C. So, TD with respect to C. So, X bar is measured from D kasi siya yung numerator. So, X bar D. Sign convention for the tangential deviation, it is positive if the final position of D is above the tangent at C. So, this is an example of positive tangential deviation. Kapag negative naman, it means that the final position of D is below the tangent at C. So, pag nasa taas naman yung tangent. Okay? Now, as I said, we will, if you solve quiz number 2 of the previous lecture, you will see that it's particularly difficult to find areas inside the M over EI diagram kasi meron kang spandrels, etc. So, putol-putol na spandrel. So, for this lecture, we'll be discussing how to derive moment diagram that are constructed by parts or piece by piece. So, let's illustrate that. So, let's check at different types of common loads that are applied to beams, and then the corresponding moment diagrams of each kind of load. Okay, so our first kind of load is an applied moment. So all of these loads, we will be assuming the cantilever. So yun gagamitin nating reference section. So if you draw the moment diagram of a load like this, the degree of the load is considered as -2. Dito, di-discuss ko kung bakit, paano nalaman na -2. Ha? So the moment diagram for M, applied moment, is a rectangle. So the slope is 0. So the degree of this curve is 0. So lagi kasi -2 yung the degree of curve from the, -2 of the degree of curve papunta dun sa load. Okay? So the value of this one is M naught, or basically kung ano yung value ng applied moment. Now the direction, whether this is positive or negative moment, can be determined from the direction of the moment. If you see here, the moment of this force about this point, yung ka-equilibrium niya, ang moment niya pa ganyan. Yan. So this one is positive bending, kaya positive yung ating moment. So doon ko nalalaman yan. So how to find the values, or an easier way, pag nakaturo sa taas, yan, pataas. Pag nakaturo sa baba yung moment, so negative naman siya. Okay? So how about kapag point load, force P? So you can imagine the degree of this load is -1, so +1 lang ito. And then the moment diagram, corresponding moment diagram, or kung hindi nyo madiretso sa moment diagram, subukan nyo muna yung shear diagram. Shear diagram nito, papataas, dire-diretso, tapos bumaba. So, yung triangle na yan ay ganyan. Moment diagram niya. Moment niya about this point is -PL. So, kaya, it is a first degree curve. So, kapag force, kapag moment, rectangle. Kapag force, triangle. Now, again, para nalalaman na negative, so check nyo lang, yung moment niya about this point sa fixed end is clockwise. So, yung ka-equilibrium nun is counterclockwise. Ito yung equilibrant. Diba? So, yung reaction dyan pa ganyan. So, this one causes negative bending. Kaya siya, negative. Now, yung value naman niya, moment lang. So, P times L. So, PL. Now, an easier way of remembering yung direction, so pababa itong force, dapat pababa siya dyan. Now, bakit siya naging triangle? You can imagine, as you go nearer, papunta kay P, palit ng palit yung moment niya. Kaya siya linearly decreasing. Okay? So, meron na tayong moment, force. So, the next kind is the uniformly distributed load. So, the degree of this load is 0. So, flat kasi siya. So, doon yung nalalaman kung bakit naging negative 2 yung kanina sa moment. Kasi 0 to, tapos negative 1 yung force, tapos negative 2 yung moment. Now, the moment diagram of this one looks like this. So, parabolic curve na siya, or a second degree curve. So, second degree curve with vertex pointed at this point, kung saan M is 0. Yan, dyan yung vertex. Now, yung value, ito, is the moment of omega about this point. So, for example, ito, ang force, magiging force yan, para magiging force siya dito, that would be omega times L. Omega times L. So, para maging moment, you multiply it by L over 2. So, kaya nagiging omega L squared over 2. Yan. Now, again, pababa siya, so this is negative. This is a negative moment. So, yan po kapag distributed load. Now, kapag triangular load naman, so this one is degree 1, kasi yan, linear na siya. So, yung moment diagram niya na nagko-correspond sa kanya is a cubic curve or a third degree curve. Now, again, this is negative moment, kasi pababa yung distributed load. So, yung moment niya, negative. Now, paano nakuha itong value na to? Baka mahirapan kayong ma-memorize. So, to do that, kung di siya ma-memorize, moment lang po yan nung triangular load about this fixed support. So, for example, paano to maging force? Yung force can act somewhere here. Yung value nun is 1/2 times omega times L. Yun yung force, di ba? Tapos, you multiply it by its moment arms. Itong moment arm na to is L over 3. So, 1/2 omega L times L over 3 is omega L squared over 6. So, yun, dun po nakuha yan. It's negative siya kasi nasa baba. So, you can actually expand this to other loads. So, second degree span rin. So, ito magiging fourth degree curve lang. Dagdag lang sa dagdag. Third degree span rin, so fourth degree naman. Tuloy-tuloy lang po siya. Now, I want to take part of particular note of the orientations of these loads. Papansinin niyo, itong distributed load, kailangan sagad dun sa fixed support. It's siya for this to happen. Kung saan siya nakadikit, doon yung malaking side ng parabola. Same goes for the triangle. Kung saan malaki yung side ng triangle, doon nangyayari yung moment na omega L squared over 6. So, hindi po dito sa flat side, ha? Dito, sa malaking side. Now, how do we apply that to other beams? To illustrate that, you have here a loaded beam. So, multiple loads siya. Meron kang distributed load, applied moment, and a force. Now, you can hopefully imagine this can be decomposed into a distributed load, a moment, and the force. So, parang hinati-hati lang natin yung load into 3. And then, we take into account the effects of each. So, for example, itong distributed load, yung nagiging support niya dito, kung 4 times 2 yan, so 8 kilonewtons yung force, yung moment is 8 kilonewton meter. Kasi 4 times 2 times 1, 8 pa din. Yung moment na to, 30, so 30 din yan. Pero man 5, so force, reaction force is 5 din. Yung moment naman is 5 times 4, so 20. So pag tinignan niyo, pag sinam natin, for example, yung forces dito sa support, 5 plus 8, 13 pa din. Yung moment naman, 8 plus 30 plus 20, that's still 58. So babalik lang tayo dun sa original. So kaya, sum niyan ay babalik ka pa rin sa original. Now, how do we apply that to the concept of moment diagrams? So ito, kapag ginawa niyo ng moment diagram yan using our traditional method, ito ang kakalabasan na itsura niya. So meron kang line, then may jump dahil dun sa applied moment, then meron kang moment, spandrel dahil dun sa first degree, 0 degree load. So, kaya naging ganyan. So, medyo ganito yung itsura nung sa inyong earlier quiz. So, kaya nahirapan kayo sa pagkuha ng area nung ina-apply nyo na yung area-moment method. So, by superposition or by diagram by parts, we can actually check yung isa-isa. So, unahin natin itong distributed load. So, sabi natin, pag distributed load, papunta dun sa reference section. So, ang reference natin dito ay kung saan yung fix. So, in this case, ito. Section A. So, 0 degree. So, dapat, your distributed load is a second degree spandrel. Second degree spandrel. So, paano naman nalaman kung positive o negative? So, nakaturo sa baba. So, this one is negative. Now, the value, kung ano itong value na to, paano nakukuha yan? Again, pinag-usapan na natin yan. Moment lang po yan ng distributed load. So, for example, 4 times 2 para maging 4. So, that is 8. Acting at 1 meter from 8. So, 8 times 1, 8 pa rin. So, 8 kilonewton meters. So, yung moment niya. Sige, next naman, yung moment. So, applied moment, kapag applied moment, siya naman ay rectangle. Now, paano nalaman kung saan nakaturo kung positive or negative? Ayan, kung saan nakaturo siya. So, sa baba, so therefore, it is negative. Okay? Kasi yung value, kung ano yung value ng moment. So, 30, so 30 na po. Kasi yung moment ng applied moment anywhere is still negative 30. So, now, I want you to notice kung saan nagsisimula yung spandrel sa rectangle. Ito, yung spandrel, nag-start kung saan nag-start itong distributed load. So, sa 2 meters. So, doon lang din nag-start yung distributed load na yan. So, doon lang din nag-start yung moment diagram. Same goes for the rectangle. So, nag-start, doon din siya nag-start. Okay? So, next is applied force. So, si applied force naman, nag-start sa dulo. So, kapag force, sabi natin it is a triangle. So, triangle. So, first degree. So, linear yan. It is negative kasi nakaturo sa baba. Negative. Now, how about the value? Para nalalaman itong value ng moment na to. So, that is just 5 times 4. So, 20. So, notice, nag-start siya kung saan nag-start yung 5. So, dulo ng view. So, if you take the sum of these 3, pabalik ka pa rin dito. Sa moment diagram na yan. So, paano ko nalaman? For example, itong rectangle na to, ito lang din yun, di ba? Itong part na to. Kasi wala namang effect itong dalawa. Blank, blank, plus triangle. So, triangle. Ito naman, rectangle plus spandrel plus triangle equals this. So, nasaan yan? Parang ito yan. Rectangle, ulit. So, ito, triangle, plus yung rectangle, ayan, naging ano lang siya, parallelogram, plus a spandrel. So, ganun lang po yung kinalabasan niya. So, take the sum, for example, ng values. At this end, negative 58. So, negative 8 plus negative 30 plus negative 20, balik sa negative 58. Dito naman, at x equals 2. So, 0 plus negative 30 plus 10. 10 yan kapag kinuha nyo by similar triangles. So, 30 plus 10, 40. 0 plus 0 plus 0 equals 0. Same lang po yan. So, this method allows us to parang dissect the moment diagram into its parts such that they are common shapes instead of analyzing shapes that are weird. Meron tayong shapes na kaya natin kuhanin yung area and yung centroid. Yun kasi mahalaga sa area-moment method. Area and centroid. Kasi nga AX bar. Diba? So you can get the area of a spandrel, area of a rectangle, area of a triangle. Instead of an area of this kind of shape. So ganun po yung ginagawa natin. Moment diagram by parts. Now to illustrate that, here's our first example. It's the same example as your DIM, pero minodify ko lang, inalis ko yung force dito sa C. So you will see the effects of that in the following video containing the written solution for this problem. Okay, so this is example 2 of AMM. So we have here a 3 meter long cantilevered beam. So since cantilever siya, case 2 dun sa ating mga diniscuss na cases wherein you're not loaded until the end. So hanggang B lang yung load in this case. So EI is given as a constant. So 200 gigapascal si E, 65 million si I. Therefore, 13,000 kilonewton meter squared yung flexural rigidity ng beam na ito. Okay? So the first step for AMM is coming up with your M over EI diagram. Now, since we already discussed how to determine M over EI diagram using moment diagram by parts, your first option should be to come up with your reference section. So you can actually choose A, B, or C in this case. So, papakita ko lang yung pagkakaiba ng moment diagram kapag B tsaka kapag A. Kasi kapag C, hindi siya ganun ka-advisable dahil wala namang load doon. So, pakita natin yung advantages and disadvantages ng bawat isa. So, first things first, we come up with your free body diagram. So, since fix ito, so we have to apply a reaction here. So, let's call that RA. And moment, ganito, MA naman. So, yan po, yung reactions, RA and MA. Now, if we use yung A for our reference section, A, ang main advantage is that we no longer have to take into account yung reactions na to. Why? Kasi nandun na sila. So, wala silang mabubuong shape on their own. So, kung A yung gagamitin natin, wala ng RA tsaka MA. Pero, ang disadvantage naman niya, yung triangle is not adjacent to the section. Ibig sabihin, hindi siya papataas. So, if you look at the derivations earlier for different loads, for triangles, it must, the large side must be on the reference section. So, dapat papaganon yung triangle. So, ang main disadvantage kung A yung gagamitin natin ay, kailangan nating buuin yung rectangle na to and add a triangle like that. Para nakaganon na siya. Nakadikit na ngayon dito yung triangle na kakalabasan. So, that's one way, or we can use B as our reference section. Si B naman, ang main advantage niya, wala nang dagdag bawas. Ibig sabihin, yung triangle nakadikit na kasi dun sa B. Nandun na siya sa side na yon. Ang main disadvantage naman niya, since B yung reference section, may effect si RA tsaka si MA. So, papakita ko pareho ha. So, first, let's look yung kapag A as reference section. So, kapag A as reference section, our loading has to change. So, as we said earlier, yung loading dapat mapuno ngayon itong triangle na to. So, imbis na triangle, parang nagdagdag tayo ng kalahating ng rectangle pa na triangle pa na isa. So, para maging ganyan. So, this would be 30 kilonewton per meter. Pero dahil nagdagdag ka basically ng triangle sa taas, kailangan magdagdag ka rin ng triangle sa baba. Pero para ma-cancel out yung pababa, dapat ang dagdag naman natin ay papataas. So, magiging ganyan yung loading natin. So, this is 30 kilonewton per meter. So, you have here RA and MA. So, your M over EI diagram would now look like this. So, again, ang A yung reference section natin. So, ito, for this, yung rectangle. So, yan ay curve na papaganyan. So, this one is a second degree curve. Ang value nito is just the moment of the rectangular section. So, that would be 30 times 1.5 para maging force times yung moment arm na 1.5 over 2. That's why if you check our earlier slides, this says that it's omega L squared over 2. So, yan po yung kakalabasan nito. So, let's check kung ano yung 30 times 1.5 squared. So, that would be 135 over 4. Do not forget about EI. So, this is M over EI diagram. Okay? So, 135 over 4 second degree. So, yan pa lang yung para sa rectangle. Na yung triangle naman, since papataas yung triangle, so papataas din itong curve na to. So, since this is a triangle, first degree, so this becomes third degree. Now, ang value naman nun, again, is just the moment. Kung di nyo maalala yung naka-discuss dun sa slides, you can just get the moment of the triangle about the reference section. So, that would be 1/2 times 30 times 1.5. So, force na siya. times moment arm. So, 1/3 ng 1.5. So, 1.5 for 3. So, that is equal to 1/2 times 30 times 1.5 over 3. That is 45 over... That is 45 over EI. So, 1/2 times 30 times 1.5. So, force na siya. Times 1, tas 1/3 ng 1.5. So, that would be 45 over 4 EI. Okay? So, this one is positive. This one is negative kasi nasa baba siya nung point na yan. So, yan na yung buong M over EI diagram kapag A is your reference section. Now, what if I use B as my reference section? So, if B is my reference section, ano naman itsura niya? So, parang i-imagine nyo lang na si B yung fixed support. Yan. So, if that is B, so yung loading natin looks like this. Retained lang siya. So, this one is 30 kilonewtons per meter. Meron ka ngayong RA tsaka MA. So, you can find the value of RA and MA using equilibrium as statically determinate naman yan. But, let's leave that first. Hayaan muna natin siyang RA tsaka MA. So, let's draw the M over EI diagram. So, again, si B yung parang finifix natin. So, M over EI. So, si triangle muna. So, paganyan na siya, paganyan. Pababa naman kasi pababa siya dyan. First degree, so third degree yan. Now, again, the value of this one is just the moment of the 30 kilonewton per meter rectangular distributed load. That would be 1/2 times 30 times 1.5 times 1/3 of 1.5. So, that is negative 45 over 4 EI. Yung negative dahil nasa baba po siya. So, negative ito. Okay? Now, si RA, assuming yan yung tamang direction niya, papataas. So, force. So, dapat yung corresponding na moment niyan ay ganyan. Papataas din. So, this is positive. Now, yung value naman nito would be the moment of RA. So, that would be RA times moment arm na 1.5. So, this is 1.5 RA over EI. Now, the last one is yung moment. So, si moment, kung pag ganyan yung direction niya, counterclockwise, so dapat yung madagdag sa atin is a rectangle. So, imagine, extra po ito ha, pag ganyan. Yan. So, that rectangle, pwede ko na may patong dito, pero para lang malinaw, hindi natin ipapatong. So, this one is negative, nasa baba po siya. Ang value naman niya is the moment. So, that would be MA over EI. So, as you can see between the two, the more simple one is this one. Dalawang shapes lang kasi, isang positive at isang negative. Ito, tatlong shapes. So, ang advantage niya, hindi tayo nagdagdag bawas, pero ang disadvantage, mas maraming shapes, tsaka kailangan pa ating alamin yung value ni MA tsaka ni RA. Ito naman, ang disadvantage niya, nagdagdag bawas, pero ang advantage niya, hindi natin sinulog si MA tsaka si RA. So, mas konti pa yung shapes. So, we will now use A as our reference section. We just illustrated yung difference between the two. So, 45 over 4 EI. So, yan yung difference nilang dalawa. So, again, ang value nito is negative 45 over 4 EI. Yan yung kakalabas. Okay? So, doing that, so ito na yung gagamitin natin, ha? So, our first question is the slope. So, letter A, ang tanong sa atin ay theta at C. So, theta at C, by the first theorem, theta C minus theta A is equal to phi C with respect to A. Bakit A yung ginamit natin na reference section? Because A is a fixed point. Now, ang difference is, will this hold? Ang kailangan nyo isipin ay, curved ba yung buong beam as it goes through the whole deflection. So, ibig sabihin, we have to first draw a deflected curve. So, let's try drawing a deflected curve. So, ito po siya. Ngayon, pag nag-deflect yan, dahil hanggang gitna lang yung load, hanggang gitna lang yung curved part, tapos after that, straight na siya. So, ito ay curved, ito ay straight. So, curved from A to B, tas kung ano yung angle doon, yun na yung kadiretso nito. So, this angle, right here, is the slope at B, kasi B pa lang po yun. Now, this angle is what we're looking for, theta C. So, we can find theta C if we find theta B. Bakit? Ano bang relationship nila? Since straight na ito, theta C is just equal to theta B. So, ito, ngayon, dapat ang sinosolve natin is theta B instead of theta C. Hindi nag-hold dito kasi hindi kumpletong, hindi siya dire-diretsong curve. Now, if you mathematically apply, same lang naman, pero for this case lang yun, special case. Pero in general, hindi nagiging true ito kung hindi siya curved. So, our correct equation is finding theta B, which is, if we deduct theta A, would be equal to theta B with respect to A. So, doing that, this is just equal to area from A to B, which is the definition of theta. So that's the second area-moment theorem. So, unahin natin yung pagkuha ng theta A. Since fix yan, ito po, fix, theta A becomes 0. So, fixed support kasi siya. So, therefore, theta B is just theta B with respect to A, which is area from A to B. So, yung area na yan is just the area from A to B. Area of RM over EI diagram. So, ano yung area ang kakalabasan natin? So, theta B equals area. So, yung nasa taas muna. Third degree spandrel. So, 1/4 times width, which is 1.5, times height, which is 45/4 EI. Minus, ito naman nasa baba, second degree spandrel. So, that would be 1/3 times width, 1.5, times height na 135/4 EI. So, ulit po ha. Ito po ay itong third degree spandrel. Ito namang second term is yung second degree spandrel. So, area from A to B lang po yan. So, if we calculate this, so check natin kung anong kakalabasan. So, 1/4 times 1.5 times 4.5/4 minus 1/3 times 1.5 times 135/4. So, that would be negative 10,053/64. So, just to check, 0.5 times 45/4/4 minus 1.5 times 135/3/4. So, negative 405/32 EI. So, yan po siya. So, the negative answer tells us that it is clockwise, number 1, and the value, we can now divide by EI. So, if we divide that by EI, so sabi sa atin, EI is divided by 13,000. So, yan po ang kinakalabasan. Negative 9.7 times 10 to the negative 4. So, that would be 0.00097 radians. Tapos negative, so siya ay clockwise. Now, this is theta B, but this is just equal to theta C because this is a straight line. So, yan na yung answer natin for the first part of the problem. Okay? So, the next part deals with the deflection. So, letter B is delta C. So, nasaan ba si delta C? So, delta C is, if this is the final position of C, this is delta C. Delta C. Now, if I get this distance right here, that would be delta B. So, kapag nakuha ko na si delta B, we just have to add this distance from here to here, makukuha na natin si delta C. So, unahin natin si delta B. Since itong part na to ay curved, so if we draw the tangent line at A, straight line lang siya. So, ito po, tangent line at A, straight line. So, ito yung final position ni B, ito yung tangent line at A, therefore, this distance is also equal to TB with respect to A. So, final position ni B to the distance at to the tangent line at A. So, TB with respect to A. Now, you should be wondering, bakit hindi ito equal sa TC with respect to A? Kasi final position naman to ni C, ito naman ay tangent line at A. That is because this is not a curve. So, ganyan pinag-usapan natin sa case 2. So, kaya kailangan natin kuhanin muna yung delta B, then add this distance. Now, what is this distance? Ito po, na ano ngayon tong distance to? If this is theta B, this is a straight line, so tangent theta B is just this distance over this distance. Ulit, tangent theta B is this height times this distance. This distance is 1.5, so therefore this distance is 1.5 times tangent of theta. As we said, tangent of theta for very small angles is just equal to theta. So therefore, this distance is 1.5 times delta theta B. So ito na po yan, itong natira. Such that our equation relating delta C is TB with respect to A, ito po yun, plus 1.5 theta B. So meron tayong value ni theta B, check na ito. What we need is TB with respect to A. So TB with respect to A is equal to area from A to B times x bar. Now again, pag nakalimutan nyo pa rin po, it's always x bar about the numerator. So x bar B. Okay? So again, we look at our M over EI diagram. AAB. So unahin natin ulit yung nasa taas. Ito pong third degree spandrel. So that would be area 1/4 times 1.5 times 45 over 4 EI. Kinopya ko lang po yan dyan. We have to multiply by x bar B. So x bar B. So ang centroid ng third degree spandrel is nandito. So that would be n 1 over n plus 2. Kasi n plus 1, 4 times n plus 1 time over n plus 2 siya from the vertex. So therefore, ito ay third degree spandrel. So nandun siya sa 1/5. 1/5 ng 1.5. So ito po yung x bar. Minus triangle, ito naman yung second degree spandrel. So area is 1/3 times 1.5 times 135 over 4 EI. So we have to multiply this by x bar. So ang x bar naman yan, kung ito ay second degree spandrel, so siya naman ay 1/4. 1/4 naman ni 1.5. Okay? So you compute this one, TB with respect to A. TB with respect to A. So computein lang po natin siya. 1.5 times 45 over 4 over 4 times 1.5 over 5 minus 1.5 times 135 over 4 over 3 over 4 times 1.5. Yeah, negative 81 over 16. 16 EI. Now, ano yung sabihin ulit ng negative sign? The negative sign tells us that B is below the tangent line at A. Tama naman. Kasi ito yung ating deflected curve. B is below the tangent line. So to make sure, kakalculate ko ulit. 1.5 times 45 over 4 over 4 times 1.5 over 5 minus 1.5 times 135 over 3 over 4 times 1.5. Last, 1.5 times yan, negative 81 over 16 EI. So, we now have a value for theta b and TB with respect to A. Now, you should be careful with applying these values. You can see that negative ito, negative ito. This is just a geometric relationship. What does that mean? Dapat ito, absolute value, absolute value. Kasi we're dealing with distances lang. So, kaya huwag kayo malito dun sa sign. So, kaya kailangan applicable yung inyong curvature. The science is just there to help you determine if tama ba yung inyong deflection curve. So, dito, sinasabi sa atin, for example, negative si TB with respect to A. So, dapat below si B nung tangent at A. Okay? So, we now solve for delta C. So, i-apply nyo lang po, 81/16 plus 1.5 times theta B. So, siya po, ang kakalabasan niyan is 1539/64 EI. So, this one, if you apply the value of EI, this is equal to 0.0018 meters. Ito po, sabi ng diagram natin, downwards, or that is just 1.8 mm downwards. So, yan na po si delta C. Okay? For this problem, the answer is 0.0097 radians clockwise sa C. So, yun yung slope at the free end. The deflection at the free end naman is 1.8 millimeters downwards. So, hopefully you understood that example. So, isa siyang example ng cantilevered beam na hindi nag-e-end dito sa, hindi hanggang dulo yung load. Okay? So, next example. So, ito naman is a simply supported beam with an overhang. So, loaded until the end. We're asked for maximum deflection. So, it's, again, similar to our previous examples, but now we're using AMM or Area-Moment method to solve. So, sige, follow nyo muna yung next video for the solution of this problem. Okay, so example number 3 for AMM. We have here a simply supported beam with an overhang. So, what we're asked for is the maximum deflection. So, maximum deflection along the beam. So, as we discussed in earlier problem, maximum deflection for simply supported overhangs can be a bit tricky because you have two candidates. So, your first candidate is where the beam will have a slope of 0 kasi dun pinakamataas yung curve. The other candidate is on the overhang kasi pinakamalakas naman yung deflection for this side dun sa overhang. So, yun yung kailangan nating i-check for this problem. So, two scenarios. But first, we have to determine, just like with our previous example, the first step for AMM is come up with your M over EI diagram. So, your M over EI diagram is basically a moment diagram. Pero since marunong na tayo moment diagram by parts, we can now start by selecting our reference section. To do that, we need to find the reactions first. So, for this problem, makikita natin na yung reactions equal sa 28 downwards here sa A, 28 kilonewtons. Dito naman, 76 kilonewtons yung magiging reaction niya. So, 76 kilonewtons. So, 76 kilonewtons. So, you can do that using equilibrium. Next, again, sabi ko nga, kuha tayo ng ating reference section. So, let's use D as our reference section. So, ganyan yung pag-construct sa kanya. You're basically visualizing D as a fixed point or as a fixed section. So, dun tayo nagmo-moment for every point. Okay? So, unahin natin yung pinakamadali, yung 28 kilonewton force. So, yung 28 kilonewton force, kapag point force, your moment diagram is a triangle. So, lakihan lang natin para ma-exaggerate. Yan. So, it's a triangle going down kasi downward yung force na yan. So, negative yung moment niya about D. Now, the value of this one would be the moment of the 28 kilonewton force. So, that would be 28 times this distance, which is 4. So 28 times 4, that would be 112 over EI. Why EI? Kasi this is a M over EI diagram. Okay? So, yan na yung pinakamadali. Next one is the 64 kilonewton moment. So, kapag moment, it is a rectangle. So, since, para malaman nyo yung direction, tinan nyo lang yung direction ng moment. So, sabi ni moment siya ay papataas. So, that causes a positive moment. So, from C, rectangle, pag ganyan, papunta kay D. So, this one is positive. So, ang value niya, since 64 yung moment, yun na yung moment niyan. 64 over EI. Okay? So, yung 676 kilonewton force naman, wala siyang moment kay D kasi dun siya nag-act. So, disregard na natin yan. Last yung distributed load. So, that is a uniform. So, 0 degrees. So, yung moment niya would be a second degree spandrel. Second degree. This one is going down. So, this is negative. Now, the value of that one, kung hindi nyo pa po na-memorize, is just the moment of this distributed load about D. So, moment lang tayo doon. So, that would be 24 times 2. So, para maging force times moment arm. So, ito ay 2. So, yung moment arm niya ay 2 over 1. 2 over 2 pala. 2 over 2. So, 1 half ng 2. So, this would be 48 over EI. So, yun yung value ng moment doon. So, complete na yung ating M over EI diagram. The next step is to come up with deflection curves, approximate deflection curve. So let's say that this is our beam. Hinabaan ko lang ng konti. So this is A, this is point C, this is point D. Habaan pa natin para maging mas exaggerated. Yan. So this would be B. Okay? So, paano siya magde-deflect? So, let's say this is point D, this is point A. Since pin and roller si A at D, dapat hindi mag-deflect dyan. Walang vertical displacement, pero may angle. So, since itong distributed load ay papababa, so bababa ito namang moment, pa ganyan, so, we can assume this to be like this. So, dapat mag-0 kay D, tapos tuloy-tuloy na naka-curve hanggang sa bumaba. So, approximate lang po yan, ha? So, now, what we're looking for are 2 points. So, yung 2 candidates natin, ito yung isang candidate. So, this would be delta B. Tapos, itong point na to, kung saan mag-flat yung tangent line. So, let's call that point H. So, this would be delta H. Okay, so yan yung 2 candidates natin. So, unahin natin isolve si delta B. So, for delta B, so since this is a simply supported with overhang, loaded until the end, so case 4 siya. So, hindi siya yung, hindi yung walang load. So, kapag may load, we just have to find a tangent line. So, hopefully, you saw that ang ginagawa dun ay kukunin yung tangent line dun sa nearest support, so sa D. So, ito yun. D. So, itutuloy natin siya hanggang dun sa kabila. Okay? So, yan po. So, this distance right here is the final position of A to the tangent line at B. So, this can be determined as TA with respect to D. So, tangent at D, final position of A. Ngayon, nasaan naman si TB with respect to D? Ito yung final position ni B, ito yung tangent at D. So, this distance is TB with respect to D. So, yan yung i-relate natin na distances. Now, again, you might be wondering, how did I assume that TB with respect to D is less than delta B? Pwede namang nandito yung tangent line, di ba? So, that's just an assumption. We will check that later. So, how do we check that? If TB with respect to D is positive, ang ibig sabihin nun, si B dapat mas mataas dun sa tangent. Kapag negative, ganyan. So, mas mababa siya dun sa tangent. So, yun yung aalamin natin. So, isa-isahin natin muna. So, first, let's determine TB with respect to D agad para ma-check na natin yung ating assumption. So, TB with respect to D is just area from PD, area BD times X bar, now measured from the numerator B, X bar B. Okay? So, tingin lang tayo dito sa ating moment over EI diagram. BD, so ang area lang dun ay basically itong spandrel na to. So, that's one advantage of using D as our reference section. Your only choices, logical choices, would have been D or B. Kasi nandun yung mga dulo nung distributed load. Kapag sa B, ang disadvantage, may moment pa yung 76. So, kaya pinili ko yung D para mabawasan yung shapes. So, tatlong shape lang. 1, 2, 3. Yan. So, again, area BD. So, itong spandrel lang. So, that would be second degree spandrel. So, ang area is 1/3 times base, which is 2, times height na 48 over EI. Now, huwag niyo pong kakalimutan, this area is negative. So, ayan, negative yung area na yan. So, that is only area. So, we have to multiply it by X bar. So, X bar B. So, ang vertex nito is at this point. So, that would be 3/4. So, n plus 1 over n plus 2 ng distance na 2. So, that would be 3/4 of 2. Okay? So, TB with respect to D, if you compute that one, that would be equal to negative 48 over EI. So, the negative sign tells us na tama yung assumption natin na mas mababa yung final position ni B kesa dun sa tangent at D. So, kaya negative yung ating answer. Okay? So, knowing that, ito na ngayon yung tama nating diagram, deflection curve. So, kailangan pa natin muna ito, si TA with respect to D naman. So, si TA with respect to D, that is area from A to D, times X bar again from the numerator A. So, X bar A. So, solving. So, ano yung area na yan? So, A to D. So, balik tayo kay M over EI diagram. A to D. So, itong dalawa. Rectangle and a triangle. So, yung rectangle muna. So, the area of that one is 64 over EI times width na 2. So, area pa lang ito. X bar A. So, sa A natin susukatin. So, sa A sinusukat, TA with respect to D. So, dito. So, yung centroid nito is at this point. So, this is 1 plus 2. So, therefore, this distance is 3. So, positive yan kasi positive area ito. Next is the triangle. So, that would be a negative area kasi nasa baba. So, 1/2 times height, which is 112. 112 over EI times width na 4. So, that is area. X bar A. So, to see A, so ito ay 2/3 ng 4. So, that would be 8/3. Okay? So, if we compute this one using our calculator, TA with respect to D would be negative 640 over EI. So, yan ay TA with respect to D pa lang. So, re-relate na ngayon natin yung tatlo. TB with respect to D, delta B, and TA with respect to D. Now, by similar triangles, this total distance, this distance, itong natira lang, so, that distance would be delta B minus TB with respect to D. So, yan po yan. So, kung kukunin natin yan, this distance is to this distance as this height is to this distance. Bakit hindi po yung buo? Kasi ito lang yung straight line, yung red. Hindi yung blue, kasi curved yung blue. Okay? So, the relationship between the two, as I said, is delta B minus TB with respect to D is to this distance. This distance is 2 meters. So, 2 is to TA with respect to D is to this distance, which is 4. Now, as we discussed earlier, for geometric relationships, you have to take only the absolute values. So, mahalaga po yan kasi may negative signs yung mga TA with respect to D. So, these are distances. So, solving, meron naman na tayo nito, TA with respect to D, TB with respect to D. So, the only unknown there is delta B. So, masolve na kagad natin yan. Delta B equals 464 over 3 EI. Now, sabi ni diagram, this must be downwards. Wala namang value binigay for EI, so we just let it stay in terms of EI. So, yan po ang answer. So, yan, 464 over 3 EI. So, downwards. Okay? Now, we still have to find yung maximum deflection. So, dito naman sa A to D. So, yung delta H. Now, how do we solve for delta H? What do we know about point H? We know about point H to have a slope of 0. So, ito yung tangent line niya. Tangent line. Okay? Now, you can imagine we have to use some kind of similar triangles to find this location. Kung nasaan po ba ito? Ito. Now, because our triangle from our M over EI diagram is flat, is 0 on left-hand side, it's easier to let this be the distance x. Okay? Pero ang repercussion nun, ang main disadvantage, kailangan natin kuhanin ito. Itong tangent line na to. So, this is the tangent line at A. Pagpasensyahan nyo na po ang hindi pagkakatangent. Hindi masyadong perfect. So, itong distance na to, that would be TD with respect to A. Now, hopefully, this helps you understand the difference between TD with respect to A tsaka TA with respect to D. So, ito siya. So, to help you visualize, hiwalay natin itong triangle na to. So, that triangle looks like this. So, ito po si TD with respect to A. Now, somewhere here is point H, yung deflected point ni H. So, itong distance na to, yan, that would be delta H. Tapos, itong natira, so, ito yung final position ni H. Ito po yung beam eh. Yan, yung dashed line. So, itong natirang ito, that would be TH with respect to A. Saan ko nakuha yon? This one is the final position at A. Tapos, this one is the tangent line at A. So, kaya TH with respect to A yan. So, kaya, ang relationship nila by similar triangles, so, itong distance na to, let's call that X, as we said here. So, ito namang total distance is the distance from A to D. So, this is 4. So, ang relationship nila by similar triangles ay delta H plus TH with respect to A, so ito lang, is to X as TD with respect to A is to 4. So, by this equation, what we need to find are 3 variables first. Ito, tsaka yung X. Hindi pa kasi natin alam kung saan nandun si point H. So, kaya hanapin muna natin siya. So, to do that, we need another relationship. Ano yung relationship na yun? About theta. So, balikan lang natin ito ha. This one is theta A. Hopefully, you visualize that one. This is theta A. Now, theta H is 0. Kasi nga, flat slope yan. So, ano bang relationship ni theta A at ni theta H? By the first area-moment theorem, theta A minus theta H, which is theta A with respect to H, that should be equal to the area between A and H. So, yan yung relationship nila. So, alam ngayon natin na itong theta H ay 0. So, hanapin lang natin kung saan theta A equals area AH. So, saan ba equal si theta A? Theta A is equal to T D with respect to A all over 4. So, kung kinuha yan, ito rin po yan, di ba? Ito rin si theta A. So, TD with respect to A over 4. So, dapat ito mag-equal from area AH. Area AH. So, isa-isahin natin. Pag nakuha natin si TD with respect to A, i-equate natin siya sa area AH, ma-solve na natin kung nasaan si X. So, babawasan na ito ng variables. So, unahin natin alamin si TD with respect to A. So, dito ko po gagawin yan. TD with respect to A. Para mas madali kasi nakadikit dun sa M over EI diagram. So, this is area dA x bar D. So, yun yung difference niya dito. TA with respect to D compared to TD with respect to A. So, x bar D po siya. So, solving area AD here to here. So, again, same rectangle in a triangle. So, una rectangle, 64 over EI times width is 2. X bar D. So, dito tayo magsusukat. So, that would be 1. Compare that here, ito ay 3. So, ito yung area, ito yung X bar. Yung triangle naman would be negative 1/2 times 112 over EI times 4. So, area. X bar niya, X bar D. So, galing dito, pag ganun, so 1/3 na lang. So, that would be 4/3 compared to 8/3 kanina. So, this one, if you compute, TD with respect to A equals negative 512 over 3EI. Again, to interpret the negative sign, it tells us that point D is below the tangent at A. Tama naman, di ba? Point D is below the tangent at A. Okay? So, that's TD with respect to A. Ano naman yung area AH? AAH. Ito, kailangan natin siya, AAH. So, nasan ba si H ito sa ating diagram? Hindi kasi natin alam kung si H ba is after 2 meters away from A o below 2 meters away from A. Why is that important? Kapag below 2 meters kasi, nandito lang siya. So, yung area between them, triangle lang. Ngayon, kapag kinuha natin yung assumption na H is greater than 2, so masasama na yung part nung rectangle. So, we have to make an assumption. So, first, let's assume x to be less than 2 meters. So, yan yung ating assumption, ha? So, ibig sabihin, dito sa M over EI diagram, point H is somewhere here. So, nandito si point H. Hopefully, you understand bakit nagkaganon. Less than 2 kasi. So, therefore, if I cut the triangle, this one is X. So, let's call this Y. So, ang relationship ni Y at ni X is Y is to X as this is to this. So, very simple naman yung relationship nila. So, Y is to X as this total height, which is 112 over EI, is to this distance na 4. So, this gives us a relationship Y equals 28 over EI times X. So, yan yung relationship natin ni Y is to X. Ito. Okay? So, bakit mahalaga yan? Kasi kailangan natin ng area AH. So, remember, area AH, obviously, dependent siya dun sa Y. Kasi ito lang yun, di ba? Ito si A, ito si H. So, ito yung area na yun. AAH. Sige. So, balik natin dito sa ating equation. TD with respect to A over 4. So, sabi natin TD with respect to A is negative 512 over 3. So, this becomes negative 512 over 3 EI all over 4 equals area ni AH. So, again, balik lang po kayo dito sa M over EI diagram. Itong area ng triangle. So, that area is 1/2 times Y times X. So, kasi area lang ng triangle. So, palitan lang natin to. Simplify natin yan. This becomes 512 over 3 over 4. So, ano yun? That would be so, 512 over 3 over 4 is 128 over 3. So, negative 128 over 3 EI equals 1/2 times Y, which is 28 over EI. Now, remember, this area is negative Y. Yan po, negative area. So, negative 28 over EI times X pa ulit. Ito po. So, we cancel out EI, we can solve for X. X here equals 1.7, kung tama ang aking math, 1.746. Yan, 1.746. So, alam na natin kung nasaan si H. Nasa X equals 1.746. Now, ngayon alam na natin yan, masosolve na natin si TH with respect to A. So, si TH with respect to A, that is area AH times X bar H. Okay? So, yung pong area na yun ay ito lang, triangle. So, this becomes 1/2 times Y times X. Always remember, this is negative. Kasi ayan, negative. Times X bar H. So, si H, ito. So, yung centroid dito nandito sa 1/3. So, this would be X over 3. We now have a value for X. So, Y is a function of X. So, masasolve na natin ito. TH with respect to A. So, if you solve that one, TH with respect to A is negative 24.83 all over EI. Okay? So, balikan lang natin ha. Ang main equation natin ay ito. Yan po ang ating main equation. So, nasolve natin si TH with respect to A. Ito siya. Negative 24.83 over EI. Meron na rin tayong X. Ito po. 1.746. Highlight lang natin para hindi kayo maligaw. And then TD with respect to A, nasolve na rin natin as negative 512 over 3. So, all that's left is to plug it in here. Now, again, remember, this is a geometric relationship. So, therefore, these relationships are just absolute values. Absolute values. So, if you solve that, ang kakalabasan po niyan, delta H equals, ano yung nakukuha ko? 49.67 over EI na upwards. Bakit upwards? Ayun, sabi ni diagram, upwards. So, ito ang i-compare natin. Delta H, tsaka delta B. So, alin dyan yung maximum? Ang tanong natin is max def. Max def. So, still, therefore, delta max equals 464 over 3 EI. So, siya pa rin yung ating final answer. So, hopefully, in this example, what you learned is on finding the displacement of an overhang, so delta B, and the displacement of a point of zero slope, so delta H naman. So, pinakamahalagang component dyan, two things. First is your M over EI diagram and your deflection slope. Okay? Sige po. Back to the main video.
Thank you, Mr. Lecturer. Ang kinalabasan na answer is 49.66 over EI dito in between AD. So, nangyari daw siya somewhere here at X equals 1.746 meters. And then, delta B is 464 over 3. So, between the two, ang mas malaki is yung 464 over 3. Okay? Sige po. So, that ends our second lecture on AMM. Hopefully, you understood the moment diagram by parts and how to come up with how to apply it to area moment method. So again, if you have questions, you can just email me or post in our Facebook group or comment in this video. Okay? So as your practice problem, I'm asking you to repeat quiz number 2 of the previous lecture, but now use a moment diagram by parts. So hopefully, you can see the difference between the two solutions. Same pa rin dapat yung answer, sana naman. So, tignan nyo lang kung alin yung mas madali. So, especially when coming up with area and X bar. Okay? So, here are the references for this lecture.